On April 2010, the Eyjafjallajökull volcano in Iceland erupted, spewing an ash cloud 10 kilometers into the sky. It disrupted over 10,000 flights across Europe, stranding more than 10 million travelers and costing the airline industry over $3 billion. And although it wasn't dangerous for air traffic, the ash cloud caused by the eruption had serious consequences. But while that event was relatively minor in terms of death and destruction, there are other volcanoes whose eruptions have had even bigger impacts on the world around them. And some scientists think we might be overdue for one of those super eruptions. So let's take a look at what these incredible forces of nature can really do, including how they can put our entire planet out of commission. Volcanoes are often called the Earth's pressure relief valves because they allow excess magma from deep within the planet to escape onto the surface. They happen when rock deep underground melts to form magma, which is less dense than the surrounding solid rock, so it rises toward the surface. But if it reaches the surface, then it's called lava. As the magma approaches Earth's surface, pressure and temperature fluctuate, which causes dissolved gases to come out of solution and form bubbles. This creates a frothy mixture that can trap even more gas, and when the pressure is released, the gases expand explosively, which blasts the magma or lava skyward in a shower of Tephra, which includes volcanic ash, pumice, and other materials. In a small volcano like Mount St. Noggins, this eruption might only reach a few hundred meters into the air, but in larger ones, the blast can reach tens of kilometers into the atmosphere. In 1815, the Indonesian volcano Mount Tambora produced the largest eruption in recorded history. Its eruption column reached 40 kilometers up and ejected over 50 cubic kilometers of material during its initial blast and another 60 cubic kilometers in subsequent eruptions over the following months. To put that amount of material ejected into perspective, it's enough to cover the entire United States in over 15 centimeters of ash. Most of that material stayed relatively close to the volcano, but some made it into the atmosphere where it spread around the globe. And not only did it blot out the sun in places like Sumatra where I've been, but it also caused temperatures to fall as much as 2 degrees Celsius below normal in North America and Europe for several years after. Now that may not sound like much, but remember, Mount Tambora was just one volcano. In 1991, Mount Pinatubo in the Philippines ejected over 7 cubic kilometers of material into the atmosphere. That triggered a 2 degrees Celsius drop in global temperatures that lasted for 2 years. And in 1816, the year after Mount Tambora erupted, the world experienced what became known as the year without a summer. Average global temperatures fell by as much as 0.5 degrees Celsius, which caused widespread crop failures and famine. Now, these are all events that happened in the historical record, but throughout most of history, we don't have great records of when major volcanic eruptions occurred. So to learn about the effects of past eruptions, scientists study ice cores and sediment layers. These contain deposits of things like pumice and charcoal that indicate when an eruption occurred. Scientists can also measure the ratios of certain isotopes of nitrogen and sulfur in the layers to figure out how much material was released into the atmosphere. Using these techniques, scientists recently discovered that between 12,000 and 11,500 years ago, there were more than 60 large eruptions, more than one per year. Most of these were in the tropics, but one was particularly noteworthy. About 12,900 years ago, a volcano in what is now Greenland erupted. This event, known as the 12,900-year BP eruption, injected 250 million tons of sulfur dioxide into the atmosphere. For comparison, the Mount Pinatubo eruption in 1991 injected 5 million tons of sulfur dioxide into the atmosphere. So the Greenland eruption was about 50 times larger. It was so big that it created an 11-kilometer wide crater. And the sheer amount of sulfur dioxide it released led to global cooling. Ice core records show that it caused temperatures to drop by as much as 5 degrees Celsius, and that it lowered global temperatures by about 1 degree Celsius for at least a decade. But the full impact of the eruption wasn't felt everywhere at the same time. The climate models suggest that the North Atlantic region was affected first, but it took about 2 years for the rest of the planet to cool down. But even then, the cooling only lasted 5 or 6 years in most places. Only the Arctic remained colder than normal for as long as 10 years. The reason it didn't last longer is that the atmosphere has a natural turnover time of about 10 years, meaning that air circulates through the atmosphere and replaces itself roughly every 10 years. So any particles injected into the atmosphere during a volcanic eruption will eventually be replaced with non-ash containing air. But the Greenland eruption was so massive that it actually increased the turnover rate of the atmosphere, meaning that it circulated faster than usual, which would have helped to remove the ash more quickly. And while that's good news for us, it also means that there's a limit to how cold a volcanic eruption can make the planet. Now, of course, we're nowhere near 12,900 years old, so we haven't seen this phenomenon for quite some time. But researchers say that recent eruptions in places like Alaska and the Philippines could have similar effects. For example, in 1991, Mount Pinatubo released about 5 million metric tons of sulfur dioxide into the atmosphere, which led to a decrease in global temperatures of about 0.5 degrees Celsius that lasted for a few years. Similarly, the 2022 eruption of the Hunga Tonga volcano in the Pacific Ocean released 50 megatons of water vapor into the atmosphere, which researchers estimate will increase global temperatures by about 0.01 degrees Celsius per year for the next 30 years. But not all volcanoes release heat into the atmosphere. Some actually suck it in. Take Mount Vesuvius in Italy, which famously destroyed the Roman city of Pompeii in 79 AD. Unlike most volcanoes, it's a rare type called a caldera-forming volcano, and instead of making new land, it actually collapses in on itself. These collapsing flanks can trigger giant landslides, which can then generate giant tsunami waves. For example, in 1815, after Mount Tambora collapsed, a landslide generated a tsunami that killed over 40,000 people in Indonesia. A similar event happened in 2021 when the Hunga Tonga volcano in the Pacific Ocean collapsed. The collapse triggered a landslide that generated a tsunami that hit Tonga and neighboring islands, killing 4 people and damaging countless buildings. Now, if the threshold for triggering tsunamis is lowered by an eruption or a series of eruptions, it doesn't take much to get one going. Scientists believe that a magnitude 9 earthquake off the coast of Japan in 2011 was actually triggered by steam released from the nearby Unveiling volcano. Similarly, scientists think that the 1980 eruption of Mount St. Helens in Washington state was triggered by a magnitude 5 earthquake. Now, some volcanoes are so big that they can cause multiple natural disasters at once. About 74,000 years ago, the Toba Supervolcano in Indonesia erupted. This eruption was so big that it was the only one on the 12,000 to 11,500 year time scale that scientists could detect in ice core records. It's estimated that between 2,800 and 3,200 cubic kilometers of material was ejected into the atmosphere, which caused global temperatures to drop by as much as 5 degrees Celsius for several years. So that begs the question, when is the next big one going to go off? Unfortunately, scientists can't answer that question. It's basically impossible to predict when an eruption will occur because the conditions needed for an eruption don't exist until the magma chamber is already full, and by the time that happens, it's too late to do anything about it. However, there are ways to measure things like earthquake frequency and ground deformation to get a sense of whether a volcano is getting ready to blow. And scientists regularly survey potentially active volcanoes to try to keep track of their stability. But ultimately, the best thing we can do is learn from past eruptions and make sure that we're prepared for future ones. And maybe someday we'll be able to pull off an even more ambitious feat than landing on the moon, which is landing on a volcano. If you want to know more about why humanity hasn't landed on a volcano yet, click here. Thanks for watching.